we are now doing page 4 of the momentum notes. And page 4, there are 2 problems on page 4 of the momentum notes that are exactly like the ones that are on page 3 on the bottom. I just gave you more room because there's a little bit longer problems. So let's look at number 20. It's about the 2 cars that hit each other and then skid off. And so you have to remember some information about skidding cars when we did the skidding car lap. We have a car A has a mass of 1625, so I'm going to write that down here. Mass of A is 1625. Hits another car. Car B is going to have a mass of 2175. Initially at rest, so the velocity of B beforehand is 0. In a totally inelastic collision, so the energy is all going to be conserved, but they both end up skidding off together, so the distance of the skid mark ends up being 12.5 meters after the collision. The coefficient of friction between concrete and the rubber of the cars is 0.55. It's pretty slippery, actually. We want to know what is the velocity of car A before the collision. Well, when we did this, you can start off with the conservation of momentum equations always. And what is that equation, the conservation of momentum equation, Ben? Good job. Keep saying, keep going. MVA plus MVB equals. Now, since the cars stick together, what do you got to do with the masses, Ben? Adam, great job. You're so smart. Thanks. That's after Christmas vacation. And then you're going to have the velocity of both of them together afterwards. Okay? So let's go ahead and plug in these numbers here. We have 1625 for the mass of A. I don't know the velocity of A. That's what I'm trying to figure out. Plus the 2175. The velocity of B is 0 beforehand. Equals both of the masses added together, because they skid off together here, 1625 plus 2175. And what really stinks about this is the fact that I have 2 unknowns. Well, does anybody remember that weird formula that we used when we skidded the cars down the street to figure out the velocity of a skidding car? It was, look at Kayla, way to go, girl. She is so smart. That's wow. So I got the velocity of A and B together is going to be equal to the square root of 2 Doug, or once again the distance of the skid mark times the coefficient of friction times gravity. So I'm going to take the velocity of A and B. This is after the collision. It's the square root of 2 times the distance, which is 12.5, times mu, which is 0.55. Times gravity, which is 9.8. So we're going to take all that together, and we get an answer of. So all those people got extra credit for giving the answer of 11.6 meters per second. Is that your answer, though? No. You have to plug that back in here. So I'm going to take that and plug that back in up here. Okay. And instead of rewriting it over again, we'll just put a little 11.6 down here. And now we got to figure out what the velocity of car A is by dividing both sides by 1625. And so my velocity of car A before the collision ends up equaling 27.1 meters per second. Kayla, go ahead and give yourself that extra credit point for doing that. Right. So once again, if you're a forensic scientist and you want to see who has to pay for this accident, you simply look at car A, and if car A was going over the speed limit, not only do they have to pay for the damages, but they also have to pay for all the repercussions of breaking the law. This next one is very, very long, so give yourself plenty of room to write, and it can be sort of a nasty problem. Okay, I have a billiard ball of 0.55 kilograms, and so let's just call that ball A here. The last ball is going to be 0.55, and it's moving at 1.2 meters per second. And it hits another ball, so the mass of ball B is going to be 0.45, it's all kilograms. at rest, so the ball B is at 0 meters per second. And then ball A reflects off at a 35-degree angle. So you got to go all back to this angle stuff. So let me just draw what this is going to look like. So I'm going to have a 0.55 coordinate ball moving along here at 1.2 meters per second. And it hits ball B. That's 0.45. It's an oblong ball. It has a little hard time going. And then ball A is going to reflect off at 35 degrees. So it's going to come up like this. Okay? So here's ball A. So it's 0.55 here. And let's just say this is, I'll be right there. Hold on. Really? Okay. So this is going to be 35. No, when the red button disappears, that's when I'm recording. Okay. And what we have to figure out is, it also goes at 0.89 meters per second. So the velocity of ball A afterwards is 0.89 meters per second. So velocity of A after is 0.89. We have to figure out what speed and angle is ball B going to go down here at. Okay, that's what we're trying to figure out. So this is now a 0.45 kilogram ball. Okay. Well, if you remember back when we did vectors, and we've done this pretty well over and over and over again, we did everything in the x direction. We found out the momentum in the x direction. We found out the momentum in the y direction, and so forth. So I want to do the conservation of momentum equation, but we're going to do it just in the x direction. So let's look at this for a second. So I'm going to say MVA plus MVB equals MVA afterwards plus MVB afterwards. But we're just in the x direction. Okay? Well, I'm going to have, for ball A, I'm going to have 0.55. It was moving at 1.2. How fast was ball B moving before they hit? How fast was it moving? 0. So I can just go ahead and put a 0 in right here. Ball A in the x direction, it still had a mass of 0.55, but in the x direction, it was not going 89. It was going whatever this side of the triangle is. Okay? So let me draw these here. The blue side is going to be my hypotenuse. It's going 0.89. If you want to find the adjacent side, let me draw these in all different colors here. Okay, the green side is the opposite side, but we're looking for the x direction, which is the black side. What trig function do you use to find the adjacent side if you know the hypotenuse? You know what? The cosine. Very good. So I'm going to say the cosine of the hypotenuse, of the angle rather, which is 35, times the hypotenuse, which is 0.89, and then we're going to put in ball B. So the mass of ball B was 0.45. And so this will be the velocity of B in the x direction afterwards. So let's figure out what that is. Okay, Andrea just asked a phenomenal question. She said she thought that two things always bounced apart at a 90-degree angle. They do if they're the same mass and not spinning. Here you have two balls of different mass, which often happens at a paid billiard table because the cue ball is either a little bit lighter or smaller than the rest of the balls, so it can get back to you. And so only if they're the same mass will they bounce apart at a 90-degree angle. Great, great, great point. Okay, so if you combine all this out, now I have 0.66, that's the answer to the left-hand side, equals 0.4. 0.4 is the answer to all of this part right here. So I've got to subtract 0.4 from both sides. And if you do that, you end up getting 0.26. And subtract 0.4, so I get 0.26 equals 0.45 times the velocity of B in the x direction after the collision. So that now means that the velocity of ball B in the x direction has to equal 0.57 meters per second. Now, I'm not even close to being done because that's just in the x direction. Now you got to do the same thing in the y direction. So let's do that. Okay, so let's do everything in the y direction. Guys, I'm not going to rewrite this equation. I'm just going to put in the numbers again. So now my mass is going to be still 0.55. How much is ball A going in the y direction at the very beginning if it's going straight across the board? 0. So it's 0. Ball B also has a momentum of 0, so I'm going to have 0 plus 0 now equals 0.55. Instead of cosine, what do you use to get the y direction? Sine. So I'm not going to have 0.55 times the sine. I'll raise this up in just a second, guys. Sorry. Sine of 35 times the hypotenuse of 0.89 plus 0.45 dB in the y direction after the collision. Okay, so I just went ahead and did the math real quickly for you. The 0.55 times sine of 35 times 89, all this ends up equaling 0.28. I moved that to the other side so it becomes negative. And then I divided both sides by 0.45, and this ends up being a negative 0.62 meters per second. Thank you very much, Maddie. And since it's negative, that means the ball's going which direction? If it's negative in the y direction, south, exactly right. Well, now, there's 2 more steps that are really, really easy. After you did the x and after you do the y, you now have to do the Pythagorean theorem to figure out which way the ball is going to go. And so if it went a positive 57 meters per second, this is 0.57. I said 57, I meant 0.57. And it went a negative 0.62 in the y, that's 62 in the y direction. That means the ball is actually going to come down like this, and we have to figure out how fast it's going to go. So, what formula did we use if we knew the opposite and adjacent to find the hypotenuse? What, close enough. It's a Pythagorean theorem. Very good. So you're going to take the a squared plus the b squared equals the c squared. And so c is going to equal the square root of 0.57 squared plus 0.62 squared, and that ends up equaling 0.84 meters per second. We are almost done. We got the last step, so we got to figure out the angle here. Once again, if you know the opposite side and you know the adjacent side, what trig function do you use, Chesla? If you know opposite and adjacent, O over A. Tangent, good. So we're going to take the angle equals the inverse tangent. We're opposite over adjacent. So I'm going to have inverse tangent equals 0.62, that negative 0.62 over the 0.57, which is almost the tangent of 1. So we're almost at a 45-degree angle. So the angle ends up equaling somewhere around, so we got a total of 47 degrees. You could say south of east if you had to, but just say 47 degrees down.
So you can get the square root of a negative number.
All right, so those are going to be the real hard ones that are on the test. So they sort of match up with the advanced momentum problems. Hope you have a great weekend. Love you. You're the bestest in the whole world. Is sis. You're welcome. Bye. Bye.